you in the video of the protest or something?
He said there was no.
I was there.
Oh, you said you was there when there was no protest?
I was not. They said there was protest.
Yeah.
Yeah, I was there, and there was no protest.
Maybe it was a small protest. Maybe they thought you were the protest. Yeah. All right. Now, are we missing a few people? Amali's in the other class now.
I know I just said Alman is here. Maybe he's in the other class.
Yeah.
Anyways, I haven't seen him today. And then, I think he is in the other class though.
Yeah.
And who else? Juliana's gone, isn't she? Yeah. And then, anyone else?
Daniel's gone.
Oh my, I knew you were
Yes. Now, I think he's in the other class. I think so. Now, tell me if this is okay. What I did question 1, 2, 3, and 4 with the other group, and I asked them, would it be okay if I did 5 and 6 the next group? So they will have to watch the video for this class, and then you guys will have to watch the video from that class. Yeah, so okay? That way we can move things along. So I'll call the videos are called revision 1, 2, and 3. So this is revision 3. You'll need to watch revision 2. If there are questions from it, we can do it on Monday's class. So we'll start with the calculus, which is number 5 then. But before I do, is there anything you need to clarify from 2, 3, and 4, like a word or something like that?
You have it online, right?
It'll be online later, yeah. But if you were anything 2 or
Can we do B2C if we have time?
B2, the trigonometry equation? Yeah, okay, we'll do 5 and 6, and then we can go back to that then at the end. So what we'll do is, I'll do 5 and 6, I'll have plenty of time left over. We can look at problems from 2, 3, and 4 then. Okay, so 5. Y equals x cubed minus 3x squared minus 9x plus 10. Okay. Yes? Oh, yeah. Just put it to the left a bit. Yeah. Careful. That's okay? Yeah. Right. Well, first, we want to find the turning points. So what do we need to calculate here? dy dx. 3x squared minus 6x minus 9. And that should equal 0. Dividing by 3? No. Minus 3, so this is x minus 3, x plus 1. So x equals minus 1 or 3. Now we have to get the y though, so if I put this back in, if I put in minus 1, 15 for sure, and the other one? Negative 17. Okay, so we don't know which one is the max and which is the min, so we need the second derivative here. So d2y dx squared is 6x minus 6. Alright, so if I put in minus 1 here, this will be minus 12. Yeah, so that will make this one the maximum. And if I put in 3, I'll get a positive. So that makes it the minimum. Now, if you think about this, 9 marks is quite generous. Because it wasn't that hard. You know.
So it should be like 4 minutes.
You can technically, my rule is to spend maximum of 10 minutes, but you don't need 10 minutes for this. This is part A. Okay, part B. Sketch the curve, clearly showing the turning points. Right. So x, y. Okay, where's the first turning point? Minus 1 and 15. So that would be like here. And then the second turning point is 3 minus 17. Well, I don't know, I'll just put it like here. And then we'll draw the curve in. So I have to go has to go maximum here, and then has to come down to a minimum here, and then flip back around. This question is only 2 marks, so that's why I didn't bother putting in extra information. This is all I would need for the 2 marks here. In fact, it says, do not show where it crosses the X and the Y, so I didn't bother with those points. Yeah, okay, so that's the B. The C is to solve the inequality dy dx less than 0. So in the graph, that's when the slope is negative, which happens from here to here. So actually, because this graph is -1 and this point here is 3, I believe the answer should be from -1 to 3. Now let's check that. What is dy dx? I forgot. What was it? 3x squared. And that should be less than 0. X squared minus 2x minus 3 less than 0. X minus 3, x plus 1 less than 0. Minus 1, 3 above or below? Below. So this is -1 to 3. So it is what I thought it would be.
Could you go down a bit?
Zoom out like?
Yeah. No, I mean, the see behind you.
Can't
see the last 4 actors.
Oh, I'll just move the projector up a bit.
Whoa.
Well,
Yeah.
is
Yeah. Cool.
it okay?
It's up here.
Is that better than being on the...
Yeah.
There we go.
Yeah,
Okay.
that's
Whoa, 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 we got it perfect. Yeah, nice. Ah, that's better.
Can we write down set?
Yep, what would it be as a set? This one is easy to write as a set.
Yeah.
What would it be as a set?
-1 bracket.
Oh yeah. No, no, not that one. -1, 3. Yeah? Yeah. Ah, which one? Want to use these ones, is it?
Open.
Open, yeah. Still not too bad, okay. And the last one. I don't know who, sorry, I know who writes these questions. I was going to say, I don't know who comes up with these questions, but I know who it is, so I shouldn't.
Tom from the office.
Right, so they asked you to integrate here from -1 to 0. So here's -1 and here's 0, and you integrate. One answer, this is part D. One answer is 13 1/4, and the other answer is -13 1/4. One of these is correct. Which answer?
13 over...
Why?
Because the integral is the area and the derivative of the area.
Not quite. Area, yeah. That's not quite the reason. Yeah. You almost have it. But
Because when I studied, I got taught this right about the negative numbers.
well, one way to do it is to actually calculate it. This is how you did it. Okay. Yeah. But the other way to do it is you can say part D. From the graph, we can see that y is bigger than 0 for x between, what's it, -1 and 0. Therefore, when you integrate it, the result should also be greater than 0. In other words, if you integrate a function that's always positive, the answer is always positive. If you integrate something that's under the curve and negative, the integration will be negative. Kind of like what you were saying with the area. But you have to be very careful with your choice of vocabulary. So this is the safest way to give the answer then.
So why do you always put 3 circles?
That's therefore.
Therefore, okay.
Hang on, I better double check here your math symbols. This one, this like follows, results, implies. Implies. This one. This is from. This one is if and only if, which is actually the two of these combined, meaning you can go forwards or backwards in the logic. This symbol, do we know? This is therefore. This one, do we know? Exists, yes. What else? This one here is not. This one? Oh yeah, I'm doing the logic words. These are all logic words. And then just a couple more since we don't all know them. ST is such that. RTP. That's something in biology, isn't it? Real-time passenger information required to prove. Yeah, and then the last one, which you might know, QED. End of proof.
What's the Q?
Yeah, it's in Latin.
Oh.
Yeah. Quod erat demonstratum. Yes. You know, how's your Latin? Okay.
Alpha, Omega.
That's Greek. so your Latin is not the best then.
No. But I know the word alpha, Omega.
Yeah, they're great. Is this a new one?
No, it looks like an economics test.
Yeah.
Yeah, it does actually. But is this new? QED? Maybe you use the other symbol for QED, which is a square, which means end of proof. Oh. QED or the square? Okay. You can also use, I think in places like China, they use a square. Yeah. So what do you do at the end of your proof? Just stop?
Yeah. Stop.
You did, okay. Really, when you end a proof, you should end it with this. Really. Okay, so this is useful then. There's some logic words here. I think this is, oh yeah, there's one more actually. Sorry, there's one more. This one. Yeah. For all. Yeah.
Oh, is that Latin?
No.
Doesn't need the symbol.
No. So like for example, here you could say something like, you know, you can read sentences like this. What's this? For all x, there's 6 y, such that y equals x squared or something.
Is this important?
That's a whole new language.
Yeah. But I mean, I'm telling you this because, you know, college maths books, which you might be using next year at university, depending on the course you're doing, they'll use these symbols. Maybe your lecturer will tell you them, maybe not. So if not, here's the symbols here now. These are all the main ones. Yeah. But there's other ones too, these symbols as well for or and logic things and other logic symbols. But for the ones I have here are the basic ones. Okay, so the answer is, let's zoom out. Okay, so from the graph, it has to be positive at least. You calculated it. How long did it take you to do? It was only worth 2 marks. A couple of minutes? No, it wasn't too long? Okay. Yeah. Alright, let's have a look at 6 now, which a little bit tricky. How did we do with 6? It was okay? Yeah. Harder than 5 though. Yeah. B6. Okay. Okay, so we have the curve here, which I'll just roughly redraw. This is y, this is x, and we have this curve sloping down like this, and there's a line here, and this point here is A0, and they call this point capital X. This point here is A, which is a half 2. This line is y equals 1 over x, and there's a P here at 4, 0 that goes up here. And is that all the points? X equals 4 here, is it? Oh yeah, this is the line x equals 4. And P is this point here. Q is here. Alright, so what's the first question here? Find L, is it? What do we know about L? We have 1 point?
We have 1 point, and we know that
it's a normal. It's a normal to the curve, yeah. So the first thing I'll do is I'll get dy dx. What's the derivative of 1 over x? Minus 1 over x squared, yeah. And what's the x value here at A? It's a half, isn't it? So is this minus 4? So then what's the slope of the normal, which is this line? 1 over 4. So we have y equals 1 over 4x plus c. The c is a half and 2. To get the c we use a half and 2. So 2 equals an 8 plus c. So c is 15 over 8. So we have y equals a quarter x plus 15 over 8. The line meets the x-axis. Where does it meet the x-axis? Basically, well, that's easy peasy because we just make this y equal to 0. So 0 is a quarter x plus 15 over 8. Multiplying by 8, I get 0 equals 2x plus 15. So x, which is minus 15 over 2, that's the A on the graph. Right, so far, this is all okay. Now they want the length of P and Q, to P to Q, which means they want to know what the P and the Q is, basically. The Q, actually, we can get it directly. What is the X value for Q? 4. And the Y value? 1 over 4. Very good, very good. Because we put 4 into this. Now for the P, we know what the X is. What is it? 4. And how can we get the Y? We can put it into our result here. Where's it gone? This. So what am I putting in? 4, is it? So that would be 1 plus 15 over 8, which is what, 23 over 8 or something? Yeah. So this point here is 23 over 8. So what is the length from P to Q for part C? It's 23 over 8 minus 1 over 4. The difference in the height, which is what? You have it?
21 over 8.
21 over 8 then. So that's the answer for C. So the last part, D, is a little bit tricky, area. Was it okay? I suppose we just need to break it up into how many shapes?
It was easier than
2.
we had in the worksheet.
Yeah, I'm a stinker like that, haven't I? Absolute stinker. With the hard questions I give you, yeah. Right, so I should split it into 2. Well, this is how I'm going to split it. So, what is this point here? This is a half. Yeah, so what we have here in D, we have to integrate from 0 to half. What curve or function? The line, yeah, which is a quarter x plus 15 over 8 dx plus, and then we have to go from a half to 4. And what one now is it? 1 over x dx. So now it's really just For 7 marks, it's just 2 integrations. Yeah.
Can't you just calculate the area of the trapezium?
Yeah, you could do the trapezium and then add in this area is fine too. But, you know, these aren't always going to be straight lines necessarily. Usually are though. And trapezium formula is not in the formula book as well.
Okay.
Yeah. Okay, so let's calculate this on the side here. Yeah. Should be exactly the same. You mean the piece at the start? Yeah, it should be exactly the same. Right, so let's integrate here the first one. It will be increase the power by 1, divide by the new power. So 1 over 8, yeah. Plus 15 over 8x, 0 to half, plus log x. Yeah. Okay, so if I put in a half, that's 32, 1 over 32, plus 15 over 16. And if I put in 0, I get 0. And if I put in 4, I get log 4. And if I put in a half, I get log a half. When I subtract, what happens to my logs? Divide 4 divided by a half? 8. Now hang on, this is at 31 over 32, is it?
Yeah.
We can simplify this a bit more, but I don't need to because it's in the form that they want. Yeah, so this is what I want, but what, if necessary, what is the last simplification I could do? There's one more thing I could have done here. Anybody?
Calculate the log
8. 8. Look at 8.
Oh, 2 pounds.
Yeah. So you can change this into 31 over 32 plus 3 log 2. Now, the reason I didn't do that is because the question very clearly said, give the answer in this form. But some years they might say, give the answer in this form. Yeah. Yeah. Just please be careful with that in the exam.
Is this A plus B so you give it as
This
31
one.
over 30? Oh,
Yeah.
that one?
Yeah. Okay. So what do we think about the first exam we had a look at now? Yeah. Okay, so there is time, of course. What would you like to see or talk about in 2, 3, and 4? So you said at the end of number 2. Yeah, you too? Yeah. So what went wrong for you?
Well, I already got the answer.
Well that's a problem. What about for you?
My problem is I don't know how to get forward the other end.
You didn't use that circle, did you, Sharon?
I did.
You used the circle, did you?
My roommate taught me, she's in business. I think they taught them with the circle. So we should probably.
Yeah, I don't like the circle.
I'm used to doing it with a circle.
Yeah, I tried doing it your way and I got confused.
Okay, let's have a look. This is the last one in B2. Sine 2 theta equals minus a half. Theta between 0 and 360. Right, what were my 4 letters here? I, E, S, and F. So what's the I? Inverse. So you have 2 theta is sine inverse minus a half, which is minus 30. How do you get the second angle? 180 minus the first answer. So that's 210. I step is now complete. E step, the extra answers. How do we make the extra answers? Add 360. So it's minus 30, 210, 330, and 570. This step is done. What do I need to do to simplify? Divide by 2. Theta equals minus 15, 105, 115, 265. No. Yes? No. 285. 285. That step's done. Finally, fixing. What answer requires fixing?
Minus 15.
Yeah. So 105 is fine, 115 is fine, 285 is fine, and I add 360 to fix this, giving me 345. No. Come on, this is much better than the circle. Yes.
How also use it?
Well,
Yeah, the circle one took.
yeah, because
No,
who was in the other group now saying that she did it using a circle, and then you have to change the range to 720, and then you...
She showed it to me last
She showed you this way, and she showed you this way. Vanjula, she showed you
Makes
it
sense, but
with the circle.
Yeah, it's so hard.
Yeah, isn't it? Yeah.
So you do
I think of this as IESF. These are my steps. And that's it. The only thing you need to remember is how to generate the second answer. So for sine, it's 180 minus the first. For cos, 360 minus the first. And for tan, 180 plus the first. Yeah, okay. What else? Yeah?
So when you got the second one,
The 2tan?
yes, you added 360 to minus 30 to get the third.
Yeah, and 360 to 210 to get the fourth one. And if I required a fifth and a sixth, I'd add it to the previous two.
So you keep adding 360
Yep.
to get more.
Yeah, as many as required.
And then if you want to fix it,
You are allowed to add or subtract 360 to fix any answer. Yeah? Yeah.
Both equations to
Here, have a look here. Yeah. Is it section B?
yeah.
Yeah.
Yeah, last question. No. Yeah, last question B.
Ah, yes. I think I'll do this one too, since that was a tricky one. So we'll do the last one in B4 as well. Yeah, we're doing fine. And then, if you want, you can get a start on the next exam, because the next exam will be like a homework you should try and do over the weekend, because I'll do the answers on Tuesday then, at the start of class. I'll show you which one after we do this. Okay, can I scroll down now? B4, yeah. This is the last one in B4. X is greater than 12. Log base 16 x squared minus 9 minus log base 16 x squared minus 15x plus 36 equals a half. So as I was saying with the other group, there's a few ways to start this. So we could put these together. We could factorize. What did people try to do? You put them together first. So you change this into log 16 x squared minus 9 over this, yeah? Okay, good. Then what did you do next when you tried to factorize it? Yeah, the top will be x plus 3, x minus 3, and the bottom is x minus 3, x minus 12. Yeah, equal to half. Yeah, what can you cancel there? And x minus 3. Now, you're allowed to cancel that because you know that x can't be 3, because x has to be bigger than 12. You have to be careful when you're cancelling things like this, because this cancellation is only allowed if you know that they're not both going to be 0, because you can't have 0 divided by 0. Yeah. We'll talk a little bit more about that in a bit, but anyways, everything here is legit. So we have log 16 is x plus 3 over x minus 12. Yeah, seems legit to me. Now, what do we do next? Yeah, 16 power a half equals x plus 3 over x minus 12. Yeah. Now, I had a long discussion with Angela in the previous class, 12, thank you, about if we need a plus or a minus here. Because 16 power a half is it though? Yeah. If you use the negative one, x will be less than 12, so it doesn't really matter. But it's still an interesting question. Do you or should you put the plus minus here?
No. You did say before that you have to
Yeah, but that was in situations with a root. So like for example, if you had x squared equals 9, x would equal plus or minus 3. But if I said x equals root 9, what's the answer here? No, it's only 3 actually. Yeah. Yeah, so root always means positive. So this is what confuses students. They think root means positive or negative. It does not. Root means positive. The cause of the positive and the negative is not the root, but actually the square. Because there are two possible answers. And this is why the plus and minus is introduced. Not because of the root, but because of the square. In this problem, there was no square. So there is no minus. So the answer is actually only 3.
Square always means the
Positive.
It's always together, square and root, right?
What do you mean?
By saying x is equal to the square root of 9,
You're imagining previously there was an x squared equals 9. Yeah, true. Except for here. Previously there was no. This is the point I was trying to make. So, and funny enough, I was talking a couple of weeks ago to Roland and Joan about this. Should we have the plus minus here? And I think the decision was we actually shouldn't have the plus minus here. But no matter, if you included the minus, you'll get an answer that you would just reject anyways. So here we get 4x minus 48 equals x plus 3. Yeah? So what if I get 3x equals 51, x equals 17, which is acceptable. Yeah.
Sir,
Yes.
sorry, could you just re-explain number, B61?
B6.
No, I'm sorry. It's 5, B5,
Yeah.
D. I'm sorry, I don't understand that.
Yeah, the reason is, if a curve is above the x-axis, if it's positive, like this, the integration is guaranteed to be positive. And if a curve is below the axis, the integration is guaranteed to be negative. It is impossible to have a situation like this and get a negative integration. Yeah, we drew it already. Yeah. Yep.
I have a question on B4.
Yeah.
B4, 4. Could you believe in why?
Yes, that's good. Good. In B4, part 4. Last year I said in my feedback to Manchester University that this question isn't actually on the syllabus because nowhere did we say in class or nowhere in class did we talk about the suitability of equations like this one here. Sometimes you get things on the exam which aren't on the syllabus, and this just happened. This was only 1 mark, so it's no big deal. So the question was this. They were talking about people in a town, and they said the number of people who hear a rumour, the formula is something like this. So the graph would be like this. As time goes by, more people hear the rumour. And the question is, why is this not suitable in the long term? In other words, after a long time, why would this graph not be suitable? What do we think?
For me, I say as the number of sites increase, maybe number of people not increase.
You almost have it. We can say it a bit nicer.
If people are hearing rumor, then they might, after hearing the rumor, all of them.
Yes.
How will the number of people increase?
That's it, yeah. I mean, there's only so many people in the town, so at some point it reaches a limit. Yeah, if there's only 1 million people in the town, this can never exceed 1 million. So the answer is, you could say something like N must be, what's the word we can use to say that N must have some kind of limit? And now it's not N must be limited, because limited is not the right word. Limited means something different. Like you would say a person is limited in what they do and can't do, but you wouldn't say a function is limited in this way. So does anyone know another adjective here? N must be not limited. It's like limited, has the same meaning.
N must be limited all the time.
Well, it amounts to the same thing, that the N must be limited, so it means at some point then the time is limited, that there's no point in going past it, yeah. So what's the word? It's not limited. N must be not stationary, no. No, not constant, no. It's a B.
We had very broad name in French, but I don't know the name in English.
And must be bounded. Same thing.
Metallic minimum impact.
Exactly, yeah. So N must be bounded by population, or N must be bounded. Yeah, we'll say N must be bounded, and then in brackets, city population is, so what's the opposite of infinite? Uninfinite? Anti-infinite? What's the opposite of infinite? Indefinite? No. Definite? No. Finite.
Oh my God.
Yeah. In fact, it's the other way around. The opposite of finite is infinite. Yeah. So N must be bounded because the city population is finite, but this function, is it bounded? No, is not bounded.
How can we bound it?
Yeah, you can't. Well, you would have to use a different function. You talked a little bit about this in biology, actually, because in biology you were looking at your bacteria growth. The graph is like this, isn't it? Yeah. So this graph, it looks like an exponential at the beginning, but then what is its behavior in this stage? I say like a linear. And then in this stage, it's kind of like a log, actually. So it's a bit like a log here, a bit like an E here, and a bit like an mx plus c here. That's probably the same shape for this one here in real life. It's not E. So since we have a bit of time, it's good for your general education. We'll have a look at some other graphs that would have this shape to it. Because the only graphs we've had a look at so far are linear, quadratic, cubic, exponential, log, and what else? Sine, cos, and tan. Yeah. Well, of course, there are other graphs here. We want to try and make a graph like this one, because you see this one frequently in biology. You've seen it. In maths, you'll see it. In engineering, you'll see it. So we'll have a look at what functions maybe could make this. But is that answer okay? Are we happy with this one? Yeah. Okay, let's have a look here. And there was something I was supposed to... Oh yeah, and also I want to show you what exam I'm going to do next on Moodle as well. You've started it, yeah? Okay. Yeah, what one's going to be the next one? I want to show you on Moodle. This program takes a while to open. Yes. Yeah. Come on. I did click it, didn't I? Because that would be awkward if I was sitting here waiting for it to open. I did, didn't I? Are you sure?
Go back and check.
Yeah. I clicked this one, didn't I? Yeah, okay. Alright. There we go. No, that's my internet browser now. Well, while the other program's loading, I'll show you what exam we're going to do. Ah, there we go. Alright, so let's have a look at some other functions here. Do you know we know you have tan inverse. I haven't shown you the graph for tan inverse yet, which is called, I believe, a tan on the program here. So I'll show you the graph of this one. So this one kind of has the shape that you're looking for, doesn't it? The tan inverse graph. This is, but it's not quite. It doesn't quite have that shape that you want. That curve shape. It's not quite exponential. It's more just leveling off them. But it's close. It's close. You might have to move it a bit here. But there are other ones too. So I think 1 over tan x. Let's have a look at that one. No, that one's way off. And there's other functions too. Let me just double check it. I think there's one function called logit. I don't think you've ever heard of this function. Logit. So you can see logit, logit. Yeah, I think it's pronounced logit. 1 over 1 plus e to the minus x. So there's this function here, 1 over 1 plus e to the minus x, and this one is called logit inverse x, is this function here, 1 over 1 plus e to the minus x. So let's have a look at what this graph looks like. 1 over 1 plus e to the power of minus x. So I know, I'll just zoom out a bit here. Yeah. Whoop. Kind of has more of that shape. It grows exponentially, levels off, or linear, and then flattens out at the end. But of course, the problem is this is a little bit too far to the left, isn't it? We want this kind of to be here. So thinking about our transformations, how do we move stuff left and right? What do we do? If I want to move something to the right, yeah, do I add or subtract to the x? I subtract, yeah. So how many units would we like to move this to the right? 4 units to the right? Yeah. So let me plot this one now where I move it to the right a bit. There, that's better, isn't it? Yeah. And then if this was a biology question, if this measures bacteria, maybe it's moles or something. So let's imagine it finishes at 2 instead. So I'd want to expand it by 2. So what could I do here? To expand it vertically by 2, what do I do? Multiply by 2. So let's draw this one now. See it there? So let me just put on a fresh screen. Yeah, and this is the type of graph that you'd have in biology. Colin was looking for this type of graph, so when you see him, please you can tell him that the graph is this, except we need to add a bit to the right. So how much did we add to the right? It was about 4, so it's x plus 4. Oh, sorry, yeah, of course, x minus 4 to move it to the right. And then we also wanted to expand it, so multiplied it by 2, but the number that, what does the 2 represent? The kind of the maximum here. So rather than multiplying by 2, we'll multiply it by something called a. So if you were to graph this, fx equals a over 1 plus e minus x minus 4, it will make a graph that starts at 0 and then increases up until a then. Yeah? And this is stuff you will do next year when you're looking at sort of research maths, because this is, I've probably seen this a few times in biology, yeah. Yeah, so it's a common biological curve, because most, growth curve, exactly, yeah, because most growth curves, there's an initial rapid growth, yeah, and then there's a, exponential, linear, and then, does Colin actually give these stages names?
There's lag, log, and magnitude.
Oh, very good, okay. Well, exponential will be the first one. So, exponential sounds like first phase. And then, well, this shape is a log shape, so that could be the log one. So then he calls this one the lag, is it then? Why lag?
No, lag is the last phase, when it's sort of...
Okay, so he calls the middle one log.
Yeah, I don't know what he calls the middle one, but I'm not sure the last phase is called lag.
Ask him. Okay, so just to finish, let me just show you the exam on Moodle if it's working. Wait, I want to show you the exam. I'm so hungry and tired. Please have mercy on me. Right. IFY. It's an important penguin. Does anyone know this penguin? Google and find out. Tell me next time why it's important. No, it's not Pingu. Pingu. No.
It's not penguin. It's not penguin, right?
Huh?
Oh, not penguin.
Which penguin?
It's a game.
No, not Club Penguin either.
You play Club Penguin?
No. Mark, the business teacher's children play Club Penguin. Right, so we'll leave that there. The exam you should do on the weekend that I'm going to do on Monday is this one here, Exemplar Maths Part 1. And if you get stuck, the marking scheme is above it here, the solutions. Yeah, and this one is the final exam, so you don't want to look at that unless you want nightmares.